I'm Steve Kinney, Director of Training, Compliance, and Technical Solutions for Smart Vision Lights. Welcome to our webinar. Today, we're going to talk about the Overdrive advantage, pushing the limits of machine vision. So to begin with, LED lighting for machine vision comes in a wide variety with many suppliers. Most of our manufacturers focus on getting a high output in a continuous mode, even if they want to strobe the light on and off with the attached camera to pulse follow and create framing. But even fewer of these manufacturers offer overdrive for their products to optimize their output and performance in these kind of strobed applications. Overdrive can further increase the output of a light beyond its design limits in a continuous mode. This is going to be the focus of our discussion today. So what is overdrive? Well, simply put, overdrive is getting more output from the light by pushing it past its normal limits that would be based on its continuous output level. LED lights are designed for continuous operation. The limit for continuous operation of a LED light is partially determined by the LED limits themselves, but the thermal design of the light is usually the limiting factor. So we can get more out of the LEDs, but we have to get that more heat away. And ultimately, when we have as high power LEDs as we do today, the limiting factor becomes our ability to get that heat off the LED die and into the case and out into the air to keep the light cool while we are operating it. So for every light, then there is a design limit for continuous operation, if that's what they're designing for, and we're going to refer to that as 1x output. So 1x output means the 100% design output of the light in a continuous mode, or even a pulse following where they're turning on and off, but they're not getting any brighter than continuous mode. So what is overdrive? Overdrive means that we'll operate the light at a higher drive current to get more light out of it than is possible in the continuous mode. This means we'll operate the light at a higher drive current that's some multiple of the 1x level that we established for the continuous operation of the light. The LED lighting current, the output from the LED, is proportional to the current, not the drive voltage. So for the continuous design, there is 1x, some current level that drives it to that output. And in overdrive, we're literally going to drive it 2, 3, 5, or even 10x that continuous design level. And that's why we call it overdrive, because we're overdriving that light, getting extra light, like supplying too much voltage or too much current in this case, to the LED and getting it to be just super bright like a flash bulb for a very short amount of time. But you might be asking yourself now, if we're getting so much more output from the light than the design would normally support, how is this really working inside? And how do I use it? Well, overdrive, to begin with, multiple times the light means multiple times the heat, means this light would burn up in a fraction of a second if there's no limits. And again, you see in our diagram, we're showing strobing the light, and we're showing that if you turn it on overdrive, you get a very high output from the light for some period. But because we're running it literally multiple times its limit, the light would simply hit a point and burn up in just a fraction of a second. It would look like a flash bulb that went off once and be done. So how do we control this? Well, the way we control this is called a duty cycle. And what that means is we're going to set up a maximum pulse width and a duty cycle to be imposed. This means the light will be on for only some fraction of a second, typically in milliseconds, so from a thousandth of a second to maybe 50 or even 100 thousandths in some cases. And then we're going to be off for some multiple of that period of time to let the light cool back down. So in this short on time, the light is heating very rapidly and would otherwise burn out, but in the off time, then the light is actually cooling down. And because of the thermal constant nature of the light, the heat is being pulled away by the copper traces and into the case, and the case is then an infinite heat sink to it and losing that heat out into space. So the light heats, the LED dye heats up very rapidly, but it also cools down fairly rapidly. Now, the cool down time is always longer than the on time to get that heat out and get the dye back to some reset temperature before we fire it again. But typical duty cycles vary from 3 to 20%, meaning you can be 3 on for 3% or 20% of the total period of light, and the rest period must be the remaining period of it that it's not on. More output means lower duty cycle. So we haven't really talked about levels yet, but if I run a light at 2x overdrive, then clearly I can have a higher duty cycle than if I ran it at 10x overdrive, where I would need a very short on time and a long recovery time to recoup that same amount of energy. So now that we know what overdrive is and that we can get an extreme amount of light from the LED for a very short period, as long as we rest it for some slightly longer period, we want to look at what happens when we synchronize the light in a strobing application with the camera and how we get benefit from overdrive. How are we going to use it? What kind of benefits do we get? Why do people do this? And manufacturers supply these kind of functions. So now that we've determined we can get more light from overdrive, let's talk about the benefits of overdrive. The first one we want to start with is overdrive extends the lifetime of the light. And this may be contrary to what you may think. When I often teach people about overdrive for the first time, their question to me is, how much does it decrease the lifetime of the light? And the answer is, it doesn't decrease, and it actually increases the lifetime of the light. And that's because aging effects in LED lights are largely caused by thermal effects, heat. Heat is the thing that damages the junction in the light. A light is a semiconductor junction where electrons flow into the p-n junction, fill the holes, knock off photons, which are light, and flow through the circuit. Heat slows down their process, makes fewer holes to knock off light, increases the resistance, and ultimately it's heat and resistance, which are the aging factors in an LED light. So you may think, well, when we're overdriving and we're putting out several times the power of the light, that this must age it disproportionately. And it does slightly, but you must also remember that the light is in overdrive mode with a duty cycle. The light is on for a very short time and off for a much longer period. So the product of the light output level, let's say 3x for argument's sake, multiplied by the duty cycle light, let's say 10% for argument's sake here, always results in a decrease in total average power. So if I'm 300% of my output power, but for only 10% of the cycle, then the average power is actually only 30% of what it would be if that light were continuously on. So the total product of current drive level times duty cycle always is a lower power level than the average power light if it were continuously on. This reduces heat from the light, which reduces thermal stress in turn, and ultimately makes the lifetime of the light equal or longer than if it were used in continuous mode. The next benefit of overdrive is that overdrive works well with the camera exposure and readout cycle. You can see from our diagram and illustration there that as the camera is exposing a frame for a short period and then taking a longer period to transfer that frame and read it out in the computer, that a light synchronized with that fits well with this cycle. So when the camera exposes, our light is on in the overdrive period, but when the camera takes much longer than that exposure to read that frame out, even a high-speed camera, it takes tens of milliseconds to read out a frame, then for that longer time, we can have our overdrive off period, cool the LED, and be ready for the next frame. So with duty cycles at like, say, 10%, we can support exposures upwards of 3 milliseconds and still maintain 30 frames per second with the camera, and the light just seamlessly operates behind the camera as if it were normal. You wouldn't even know it's overdrive except for having multiple times the amount of light out, the extra light. So overdrive just fits and works with the camera for very little effort. In some of our products, anyway, we build in the controller. For very little effort, you can just move the trigger from the camera to the trigger on the light, connect them, and it will begin to automatically sync with the camera, and overdrive basically provides free light at that point. And to this point, overdrive typically provides more output from the same light for free. So we do have, and we're going to talk about overdrives and types of lights coming up here, but we do have dedicated overdrive lights, both in our previous history and some of our newest products are strobe only. But many products have both a continuous and an overdrive mode. And if you use them, the same light in overdrive mode versus continuous, then you typically get 3 to 8x the light output, depending on the model of light. And instead of literally using 3 to 8 times the number of light, the physical number of lights to achieve that brighter illumination in a fixed area, you can just use one light instead. Now, this is dealing with intensity. That doesn't mean sometimes I don't want multiple lights to get light from different angles to fill in and make the scene uniform. But when you're struggling for brightness, we can get many times the more light out in overdrive than in continuous for the same model of light. So now that we've established the two basic benefits of overdrive, that we get extra light from the light for free and that it can actually increase the lifetime, what other benefits do we get? And most of the other benefits come from the fact that we have extra output from the overdrive mode and that we can use that extra light to help us do other things. We can either decrease the number of total lights, we can shorten exposure times to freeze motion. So if you're finding that you need 3 milliseconds of light to get an exposure and that's causing too much motion blur, with overdrive, we can get that down to hundreds of microseconds. You can also, the extra light can reduce the use of digital gain in the camera. So again, if you're not having enough light and you're having to add digital gain in the camera, that's going to add digital noise, reduce your signal to noise ratio, reduce your edge finding and other tools in your machine vision. And when you have extra light available, you can simply turn the gain down to unity, get less noise, and get the same exposure. Similarly, sometimes we want to use higher F number optics to get an increase in depth of field. As we go higher F number in optics, we get less light sensitivity, but in exchange for that less light sensitivity, we also get more depth of field. And depth of field is often a problem in the short working distances of machine vision. So again, if we have more light, you can do the same thing you were doing, add a higher F number, and that will get you more depth of field, which is sometimes necessary to get the right image. And the last but not the least is the extra light lets us keep exposure times low when using polarizers or other optical filters that have attenuation. We mention polarizers a lot because they have, when we use two cross-polarized linear polarizers, we can reduce glare in many applications, including logistics, where we have to read through plastic wrap and bags and other things like that. But the exchange for that is that linear polarizers, we often have somewhere between 8 and 20% of the total light. So by using a linear polarizer to reduce glare in logistics and other applications, ITS applications and so forth, then the extra light provided by overdrive mode can help us have enough light to still maintain a fast shutter speed, good low noise exposure, but use those filters that take a lot of light and lose light through attenuation. So here you see a logistics example, and you can see parts are moving by on a conveyor. This is akin to something like an Amazon automated warehouse, which made famous during COVID here. All of us now ordering from Amazon nowadays and other suppliers. And the use of automation in these warehouses increased dramatically. But if you think about it, we want those things quick. And when you look at something like an automated warehouse, the throughput is tremendous. And the vision systems that are tracking and tracing and directing the product all throughout the warehouses require on high speed. They need to see dozens, if not hundreds of parts a second passing underneath them, tagging them, IDing them, and directing them. Not only that, they have to see through many things. Imagine you're ordering anything from a coffee maker that comes in a box to a Barbie doll that comes in a little case with clear plastic film, that hard kind of translucent plastic packaging around it. And you know, boxes are dull. Plastic packaging around your Barbie is very glossy, bright. It shines back in our face when we shine bright lights at it to image it and track it and trace it in these cases. It takes polarization to see in all those cases and make it work well. Not only does it take polarization, it takes strong polarization. So logistics is a case where I would say it takes strong polarization. Often we have only 8% of the total light through these polarization filters, and thus we need an extreme amount of light to be able to image those things at the speed they are moving through the warehouse, but still use polarization and other filters to see clearly through the wide variety of objects that are passing by through the inspection station, as shown here. Okay, now let's talk about types of overdrive in lights. Up to now, we've been talking generically about overdrive as a practice from LED lighting manufacturers to get more light out of the same light and get a higher output. Overdrive is available from many manufacturers in the supply chain, though as I pointed out, of all the LED suppliers, overdrive is still a specialized thing, and the options are fewer among fewer suppliers. So look at who's providing what. But overdrive implementations vary from manufacturer to manufacturer. So we've tried to teach you the basics generically so you can take some information, look at anybody's literature or content speaking about overdrive and start to understand some things and what they may be saying to you. However, now we want to talk specifically about some benefits of overdrive, and in order to do that, we have to talk more about real products and examples. And as we get more specific, then it's necessary to talk about those products. And we're going to use smart vision lights as examples here, of course. But I want to assure you this is not going to become a marketing campaign here. We just need to provide some more specific examples of the benefits and how you might use this technology. So when we talk about overdrive and very specific implementations of types of overdrive in smart vision lights products, then we go back to the basics here in our first products with overdrive. So in the smart vision lights history, we have what we call first generation products. You don't really see them called G1, but we launched some recent G2 or second generation products, and you do see the G2 terminology coming up. But our first generation products, overdrive was so special, it required special circuits. The drive circuit, the power supplies, the things inside the light were not the same for a continuous model as they were for the overdrive model. This meant that we had to have a continuous model as a baseline, But then we had to make a separate but dedicated overdrive model. So you see in our early products that there was a continuous model like the blue one and a overdrive model like the black one. And we used the black and blue and some other color schemes to differentiate these so you knew what you were looking at. But there's a dedicated continuous and overdrive model. And when I talk about my competitors doing overdrive today, even now, it's still a special thing, and many competitors, if they'll talk to you about overdrive at all, or say, go buy my really expensive overdrive controller, or this power supply to push this, or you need the special this and that. For smart vision lights, we've always built this directly in the light. You just power the light and trigger it, and the overdrive comes for free. You don't need extra equipment and special things. So we've had these two models, and it's important to recognize that from our beginning, I've talked about the different levels. Some people offer 2x, 3x, 4x. Those numbers vary a little bit based on their parameters of measurement, but it's funny for me to hear some of that because for smart vision lights, overdrive has always meant 5 times the current, a full-on 5 times the current through the LED, which results in, it varies by model, but results in 3 to 3.5 times the light output in an overdrive mode from the same light. So early on, we had to have special circuits, separate models. But after a few years, we developed multi-drive lights. And most all of our new products, with only a few exceptions, have multi-drive of some sort built into them. Multi-drive means now we get a single product, looks like the older products, and in the case of ones in the blue casings, we made them a little darker blue to denote the new from the old, but it's darker blue because we combined the bright blue and the black, just like we combined the continuous and the overdrive into one model. So multi-drive means that in this one light, by just changing a simple signal on a pin, that you can have both continuous or overdrive, and you have a choice based on the signaling of the light. And I'm not going to dive deep in the signaling, but basically it's backwards compatible if you're using our products because the signal on the dimming pin was always 1 to 10 volts, and we just made a case, it was undefined below 1 volt, and we basically just grounded that pin to put it in overdrive. So if the pin's ground, you get overdrive. If you put a signal on it for dimming from 1 to 10 volts, or pull it 10 volts or higher for just 100% continuous output, then you can very easily control the mode of this light, totally backwards compatible with any of our other lights. So this now gets marketed as multi-drive in early releases, and for new products that we're now doing refreshes or updates on, you see the G2 nomenclature, which just means it's a second generation of a longtime family we've had, and the second generation always has multi-drive here. So now you get all the benefits of overdrive in the same model, and you can test continuous versus overdrive side by side. If for some reason strobing doesn't work out, you can just fall back to the continuous mode. We think that in most cases you're going to like, and you're going to find overdrive is just free light here. So the features and benefits for multi-drive then, you get the same as when we had 2 discrete. There's no trade-off to our discrete products. One multi-drive product still, as a standard, gives you 5 times the current and roughly 3 to 3.5 times the light output. It's easy to switch between with the signaling as I just described. The standard duty cycle for all our multi-drive products is 10%, which is fairly long. This allows for longer pulses if need be during the on time, or if the pulses are shorter, the high duty cycle allows a higher repetition rate, so you can have longer exposures and not affect your frame rate. The specs for this kind of drive also dictate that there's a 10 microsecond minimum pulse width, a 50 millisecond maximum pulse width, and the light responds in microseconds of turn on and turn off time. Those kind of specs are important when looking at the parameters for your application, repetition rate, and what you need for exposure, of course, but they're also going to be important to remember as we come up and talk about the other types of overdrive that we do. Because here's everything you need for basics in a multi-drive light. So now, let's look at an actual comparison, and this is why it was important to point out that we're going to use our own lights, or at least some sample lights which turn out to be our own, to give you real examples, because now we need to point out what you're getting. So in these two images that you're seeing on the slide, we've used an equal exposure time of about 1 millisecond through the same camera, same lens, 25 millimeter lens, f2.8 optics. And what you see is the image on the left is darker because we've normalized the exposure to the image on the right, which is the overdrive. So you're seeing the overdrive under these conditions and see that we can get a full normalized exposure. And what you're seeing is, if I didn't use the light in overdrive, then I would use it in continuous mode. And with continuous mode, I only get roughly 30% saturation like that image on the left, and it's going to be dark and shadowy. So again, if you were using lights in continuous, you would have to up your exposure time, you would have to provide a second or third light, trying to get more light, you'd have to provide a lower F number, higher digital gain in the camera, some trade-off to get that image to be bright enough to do your machine vision algorithm on it. You would much rather have the free light that came with overdrive on the right start with the brighter image and not have to do any of those things. So you can get a good comparison of why I need overdrive for a benefit and what the benefit is over continuous by looking at these two images. So now on this slide then, we're going to do the same thing, but the comparison here is, well, what if I do equal saturation level? So now you see with either continuous or with overdrive in this multi-drive light, I can get a similar looking image with similar exposure and under fixed same conditions given on the left. But what you find is that I got the image with the overdrive mode in only 1 millisecond of exposure. Whereas on the right, to get it back to the point of my previous slide, I had to increase the exposure time up to approximately 3.2 milliseconds to get a proper exposure on the image on the left in continuous mode. So you can look at overdrive gives you 100% saturation when it would only give me 25 to 30% in continuous, or you can look at it as overdrive gives me 100% saturation at only a millisecond when it would take me 3.2 milliseconds to get the same exposure in continuous mode, or some combination of exposure and saturation level to get to a point in between if you weren't going to use overdrive mode. So clearly overdrive mode has benefits, and if you're not being limited by the duty cycle or the frame time, there's really no reason not to do this kind of thing. So now that we've been talking about overdrive and the simple basics like continuous and multi-drive there, we're going to talk about other types of overdrive. And you have to start by asking, well, what else do I need to do? And one of the benefits of overdrive is, in fact, in those very short, bright pulses that we can provide. And one of the reasons to do something different than in the standard products is to get even shorter, even more accurate on those fast pulses. So we don't recommend nanodrive for all applications, but we have a few products in our line that are branded with nanodrive. And nanodrive is a very special version of overdrive aimed at highly accurate, high-speed, short pulses. So with a nanodrive, it's basically a multi-drive like I showed you. It has both a continuous and an overdrive mode. But when you put nanodrive lights into overdrive mode and trigger them, two things happen. One, you can have minimum pulses down to about 1 microsecond. So the light will accept, will turn on and turn off within 1 microsecond and give you a very short, bright overdrive flash. Whereas in our standard products, the minimum time was about 10 microseconds. The other thing that happens as you get these very short pulses is you need them to be accurate. In the standard products, even with overdrive, there's a few microseconds of latency, and then more than that, there is a few microseconds of turn-on time as we turn the light on. Even though LEDs are very fast, how fast they turn on or off is a function of how hard you drive them. And even though for most things you would say an LED is fast, when we start measuring down in the microseconds of exposure, you can see that it takes between 2 and 5 microseconds to turn on the LED. So in our lights equipped with NanoDrive, there's a special constant current engine in there, and that engine is running at full bore the entire time, just waiting for a trigger. And when it triggers, that engine at full bore just turns its output on, slaps that LED with the full constant current output already set up, and turns that thing on in only hundreds of nanoseconds. It can be fully on in a few hundred nanoseconds, stays on at 100% brightness, and turns off in 50 nanoseconds or less. And thus it's possible to have highly accurate pulses down to 1 microsecond, certainly, and in the 5 to 10 microsecond, almost negligible edge effects. So we offer NanoDrive for those applications where you need to freeze motion to the extreme. High-speed cameras, high-speed capture events, and so forth. So the features and benefits of NanoDrive, you still get the same 5x current, 3x light as you do in our other types of overdrive, and easy to switch between the modes. You still get the longer 10% duty cycle as well, but the main benefit with NanoDrive is we get 1 microsecond minimum pulse widths, and we get nanosecond response time for turning the light on and off. So on this next slide, then, we're showing you an example of motion blur capture between just standard multi-drive type of overdrive and a high-speed NanoDrive. And in this case, we're taking advantage because of the high-speed nature. We're running both of these lights at their minimum times. But for the NanoDrive, that means we can do it in 1 microsecond. And for multi-drive, we have to use 10 microseconds minimum pulse width. And for that 10 microseconds, there's actually some latency before the light turns on and slower on and off. So we're actually getting less light. We're not getting 10 microseconds of light in that very fast period at the minimum shutter. We're getting the equivalent of probably 3 to 5 microseconds worth of light. So we have to take care of that because there's a similar amount of light coming from these, but there's a longer on time in the multi-drive. That does mean that we had to turn the gain up a little bit and adjust conditions for the 1 microsecond. However, what you can see is despite that, if we look at the motion blur, we have less than 2 pixels of blur in the NanoDrive exposure on the left, yet we have somewhere around 12 pixels of motion blur at the 10 microsecond minimum on the image on the right. So you can see in the extreme case, if I was getting down to minimum exposures of something traveling very high speed, all this light helps me get to the right exposure level, but it's the NanoDrive that gives me the ultimate edge at freezing that motion. So we want to use NanoDrive where we need fast and sharp light pulses to freeze motion. So now, the next type of overdrive we're going to talk about is also specialized for many applications, and it's our newest drive called dual overdrive. Dual overdrive is named such because for the first millisecond of operation when it's triggered, it has what we call a deca overdrive. Deca overdrive meaning literally 10x the drive current. This is very extreme, provides a lot of light output for up to that 1 millisecond. 10x the drive current will generally give us somewhere between 7 and 8x the light output. So we can have a lot of light for that first millisecond. And then After the first millisecond, if the trigger is still active and the light is held on, the light internally automatically drops to our standard overdrive level, which I've told you previously is around 5x the current level. So we can have standard overdrive for up to 5 milliseconds after that. So in these dual overdrive, again, they're named because dual overdrive means it's two-step between Deca and standard overdrive. There's 2 steps. But dual overdrive lights are aimed at very high-speed applications where I need a very fast pulse of light, and I don't need more than a few milliseconds worth of shutter. In fact, most of my customers that use this kind of overdrive today aren't ever hitting the dual part. They're using 1 millisecond or less and using the extreme 10x overdrive that's available. Now, it is important to notice by the time we specialize, and this comes back to specializing lights for applications and why there's not just one size overdrive for all, we specialize this so much that with 10x overdrive, we then have to lower the duty cycle to about 3 or 3.5%. It varies by product a little bit in the dual overdrive technology. But the duty cycle is now 3 to 3.5% and not 10%. That means light can only be on for a lower amount of time and that we have to have a longer recovery period. So dual overdrive is aimed at logistics, high-speed motion capture, and other types of capture where you need that extreme amount of light and still need a moderately fast repetition rate. Even with the longer duty cycle, 3% versus 10, you're going to need to be off for 3 times as long. It's usually not a problem because the exposure time is more than 3 times shorter of a typical application. So the repetition rate in these lights can also be very good. This type of technology was developed during COVID, aimed specifically at our logistics customers and automated warehousing that's out there. But it's useful technology for any kind of motion capture where you just don't have enough light, and for all the benefits we talked about overdrive, you need more light to see through films or polarizers, you need to reduce your exposure time, you need to reduce gain, whatever it is, dual overdrive can do it for you. And the only time when you're in those kind of situations and you use a normal one is if you weren't fast and you would just prefer the normal types of overdrive to release the duty cycle limitations and expose for a longer period. Otherwise, if you're in a fast application, dual overdrive is the way to go. So for features and benefits, we get roughly 10 times the current for the first millisecond. Like I said, 7 to 8 times the amount of light. The product auto switches between Deca overdrive and standard overdrive based on the trigger pulse width. The user doesn't have to do anything. You hook it up and synchronize it with the camera. The light triggers off the pulse width coming from the camera, and any of the switching in the overdrive mode happens internal to light with the user not needing to do anything. The 3 to 3.5% duty cycle, as I said, allows for high-speed strobe operations. It is important to note that even though this is aimed at general high-speed applications, if it's the highest speed, you're probably going to use nanodrive, even though it's not the Deca overdrive, because for this type of application, we do return to 10 microsecond minimum pulse width and reduce it to a 3% duty cycle and have microsecond response time on and off. So you're going to use this where I have a fast application like logistics and I need, exposure times in certainly 1 millisecond or less, several milliseconds or less, or even hundreds of microseconds, just something longer than 10 microseconds. So now when we compare the 3 types of overdrive I've outlined, and again, we look at these in terms of equal exposure time, we've exposed these at 1 millisecond, using, again, a fixed camera setting and a lens with fixed settings. Then on the far right, you see the Deca overdrive at 1 millisecond. You can see it's the brightest image, well exposed, sharp detail. We can see that with standard overdrive compared to the Deca overdrive there, that we get only about a little more than half the saturation level. We still have a reasonable image, but it's dark and only 50%-ish saturated. And that in fact, the continuous mode, you can see there's some outline depending on your monitor there. There's details, but this image is actually less than 15% saturated. It's very dark, you've lost information, and under the same kind of conditions that provide a full saturation with Deca Overdrive, continuous mode is just really weak here. So again, looking at benefits, if I'm in a situation saying, I don't want a strobe, I'm bothering operators, I'll just do it with a continuous light and forgo strobing, you would literally have to buy 8 or more lights here to get the equivalent output of just one dual overdrive light. So consider your application and constraints, and then choose the right kind of mode, whether overdrive or continuous is right for you. If it's overdrive, look at the types of overdrive that are available. And now as I move on to the next slide, you see the same comparison again, except we've done it with equal saturation levels. So now we've let each type level out to 100% saturation, or what we've defined as 100% saturation with fixed settings. But what you can see is at those equal saturation levels, it now took more and more time with the other types of overdrive to get to that equal point, and that the fastest one to get there is in fact the dual overdrive. So you can compare these by time, you can compare them by exposure level, or some combination of the both. The more light provided by dual overdrive, it just gives you more to work with in a short amount of time. Okay, so this brings us up to our wrap-up and conclusions for our presentation today. I and others at Smart Vision Lights thank you for joining us. If you don't take anything away from this presentation, I hope that you at least learned that overdrive mode provides you extra light for free from the same light, and that by learning to use overdrive modes and utilizing them, there are many benefits, including reducing your shutter time, reducing digital gain in the camera, capturing high-speed motion, using polarizers and other films necessary to get the right image without light loss. And there are just many benefits to having all this extra light. Smart Vision Lights wants to be the go-to for the how-to for you. We invite you to bring your questions and application needs to us. We have expert help for you. Come discuss your lighting needs with us. And with that, we're going to have a brief pause while we break and go to question and answers here. And momentarily, we will start picking up questions from our live feed. If you have a question, please just type it into the chat box. We will pick and select from there and start answering the questions as we continue. Hi, and now we're back for Q&A. We apologize, we had a slight audio problem there. Now we're back. So first question we have up is, what if I want to use overdrive for the extra light output and presumably the other benefits there, but I'm using the light in continuous mode because strobing bothers nearby workers? So here we want to use the light in continuous because we kind of can't have strobing, flashing lights at camera speed or slower, a few parts per second going down a conveyor or something, bothers workers. We did not talk about it today, but related to our built-in controller and having overdrive, there is another feature on some of the newest Smart Vision lights called hidden strobe. And hidden strobe internally triggers the light. So while it's waiting for a trigger on the outside, the light is actually internally triggering itself at very short microsecond pulses, several thousand times a second, so it looks continuous to your eyes. It's flashing very fast in full overdrive mode, but your eyes see that as one continuous light. And then when we need a real flash to illuminate the scene for the camera, a true trigger comes in the line between the camera and the light. They both flash in synchronicity, and the light stops at that point, executes the commanded flash, and and gives the pre-programmed flash that it should following the pulse width. So everything works kind of the same, except outside users see this continuous. That kind of technology works only for very fast flashes, so things like logistics that we've been talking about, where exposure times are less than a millisecond typically, we can make that work well. Okay. There's next question says, since the duty cycle is heat related, can I cool the lights to get a longer maximum pulse or a higher duty cycle? Well, there's a good question. We get this periodically. So again, we have to make the general product meet the full specifications, including the temperature range from -10 degrees C to 40 degrees C. And out of that, we set the duty cycle for the light by design and make sure everything is within the envelope for that entire range. And because the controller is built in and microprocessor controlled, the controller is actually protecting itself to that duty cycle. So in firmware, you can't really change anything. So for a standard product, the answer to this is no, you have to obey the standard duty cycle. As a side note, cooling doesn't always help the duty cycle because the pulse width is instantaneous heat that we have to get from the LED die out into the light body, which is a slower thermal. So the die heats and we can get a small immediate amount into the infinite heat sink behind the LED, but that heat sink temperature is at a slower constant. So cooling doesn't always help the short-term pulse duration. However, and for standard products, that's basically the answer. However, if you have a special application, need this, you should be contacting us and talking about it. We do, for very specific OEM cases, set custom duty cycles. We can assign a standard custom part number and make a custom duty cycle. So we have cases where I'm gonna have short flashes, but 4 or 5 in a quick sequence, but then it's gonna be a long time before the next ones. We can change the duty cycle for you in cases like that, but it is a custom option. You need to be talking to our sales department. And lastly here, I see we have, can I use Overdrive with UV or NIR lights? Also a good question. We can overdrive all the various wavelengths, so yes, we can in fact use UV or near infrared or even SWIR lights in overdrive modes. And this is really important in the non-visible lights because, number one, if hidden strobe that I was talking about a minute ago is not usable for you because you have longer pulse widths or some other conditions where that's not the proper answer, then it's very common to use non-visible imaging like UV or typically NIR. UV is used in special cases, but typically they will go to near infrared. But the camera has only about 10% or less sensitivity at the near infrared, depending if we're using 850 or 950 near infrared lights, and even less sensitivity at 950. So it's important that Overdrive can help you in those cases. If you're using it, you're already down on sensitivity, you need extra light to make the scene work at the proper shutter speeds, and in fact, Overdrive will help you. And in those cases, we don't have to worry about flashing for operators or other personnel that are nearby because simply it's non-visible. So you can have all these benefits and no downside to that. Okay, so that looks like it for our questions that are coming in. I want to thank everyone again for attending today and watching our seminar here. If you do have questions or you need technical assistance, the contact information is embedded in this. Please reach out to sales at Smart Vision Lights or contact your local distributor. We're always here to help you. Thank you.